Hi there, in this video we're going to look at decoders. We're going to be using these in various places in the CPU, but the ones that we're looking at the moment are for the RAM. Okay, so let's look at a decoder. So if we had 2 bits, let's see, you can see that okay, yeah. So we had 2 bits there, okay, so that's a bit there and a bit there. Now we've got 2 bits, okay, so we put a 2 there, but those 2 bits can produce 4 different values. So the values they can produce are 0, 0, 0, 1, 1, 0, 1, 1. Okay, so this is now producing 4 values. Okay, so we've got a 2, we can produce a 2 to 4 decoder to get access to 4 values from 2. Okay, now the same thing happens for a 3 by 8, so we're going to have 3 bits. Oh, but I squashed in this one. 3 bits, okay, so there's 3 bits there. So we've got 3 inputs, and those are going to give us a maximum of 2 to the 3. Okay, 2 to the 3, I should put that up there because that's going to be 2 to the 2. Okay, that's going to be 2 to the 3 possible outputs. So all our outputs are listed along here. Right, there's 2 to 3, which is 8 outputs. Okay, so that's 8 outputs. So now we've got our 3 by 8 decoder, and we can create a 4 by 16 again with 4 inputs. Okay, and there's our inputs there, and so that's our inputs 4, and our outputs are, well, we've got 16 outputs. Okay, so that's 2 to the 4, okay, equals 16. So that we could call a 4 by 16 decoder. Okay, so that's a 4 by 16 decoder. The other one's a 3 by 8 decoder, and that's a 2 by 4 decoder. Okay, so all we're really doing is from the inputs we're getting access to each and every individual output. Right, so let's rather than, well, what I'll do is I've actually got one built, so well, I'll go through an example here of a 2 by 4. Okay, so what we would require 4 AND gates, 2, 3, so we've got 4 AND gates, and these are our outputs. Okay, so this is our least significant bit, so we say 0, 0, 0, 1, 1, 0, 1, 1, and what we want to do is we want to get these lines going high whenever these values occur at the input. Okay, so at the input we're going to have 2 inputs, say A and B, so that's A and that's B, but we need to get access to not A, okay, which is the inverse of A, and we have access to not B. Now what we do is we put A and B through NOT gates to get these. Okay, so in the first instance here, when A is 0 and B is 0, we want this to go high. Okay, so when A is 0 and B is 0, that means that in order to get this AND gate to go high, we'd have to take it from the complement. Okay, so we'd have to take it from not A and not B, because now when A and B go low, we get a high output here. Okay, in this instance here, we, let's see, A is A and B. So let's say when A is 0 and B is 1, right? Okay, we want this to go high. Okay, so in order for that to be the case, right, when A is 0, we would have to go into not A in order to ensure that that goes high, and we could just get into B. Okay, So when A goes low, not B is high, not A is high, sorry, so we get a 1 there, and when B is high, we can just take it from B and we get our high there. Okay, so all we do is connect to the respective A complement B and B complement to get whatever we require out here. Okay, so that's the basis of our decoder. So let's have a look at one, and I'm not going to build it up. We'll have one already built here in Logisim. Okay, so and it's the one that we require. It's the 16-bit. In fact, I think I might have a 3x8. Now there's a 3x8. So we'll have a look at that one there. Let's see if I can squeeze it all in. So you can see there, so that's a 3x8. So there's our input, A, B and C, okay, and there's the inversion. So we put in a NOT gate there, and we get inputs coming down here, okay, and we get the inverted inputs coming down here, okay, and you can see that there, that this is the least significant bit here, and that's the most significant bit, and you can see that in order for the least significant bit to go high, all we need is all of these inputs to be 0. So if all inputs are 0, we take the connection from the complement side, and that will ensure that that remains high. So if I want to pick the next significant bit, okay, so that's the next one down, see that there, so that's, we're going from 0, we picked number 1, okay, and you can see we've picked it from there, and all we've needed to do is we've taken the connection from the C, because the C is already high, but in order to get an output there, we needed to connect to the complements of B and A, okay, and you can see that you can work your way up. Okay, that's number 2, 3, and then to get number 4 you would turn that one on, and then 5, and then to get 6 would be that there, and then to get number 7, all 3 would have to be on, and you can see all 3 of them on there. Okay, so that is all I want to say for now. We've already got the decoder. What you can do is you can build that up, but you can build it up as a 4x16. So there's a 4x16, and it's the exact same thing again, although it's just more difficult to see because it gets so big. Okay, so but there's a 4x16. Okay, and again you can change the inputs, and you can see all the respective values changing. Okay, so that's a 4x16. So we've got 16 AND gates, we've got 4 inputs, and we've got 4 NOT gates. Okay, and these are all 4 input AND gates. So that's all for the decoder. What I've not created this instance here up here, but what I'll do is the one I've already created for the finished CPU, I can just copy it over and I'll shift it up in there. Okay, so that's all. Thank you for listening, and in the next video we'll put together the decoders and the little register we built, and also the 8-bit memory, and we'll have a look at how we can put that all together to create a RAM. Okay, thank you. Goodbye.